Swayam Prabha. Digital India. Educated India.
Now, if there are no questions, what we'll do is move on to systematic ways of analyzing circuits. Okay, we have now discussed a number of circuit elements, and they can be interconnected in any way, and we have to be able to find the solution to the network. That means that we have to be able to find the voltage across any branch, any component, and the current through any component. Okay, and this process is known as circuit analysis. Okay, and as we know, a circuit is an interconnection of a number of elements. Okay, now the elements that we know of are two terminal elements. You can have more than two terminals, but for now let's stick to two terminal elements. Okay, so as an example, let me take something. This is just some example that I'm going to show. Okay, so you see a number of elements. We have a number of current sources and resistors connected up like this. And when we are discussing circuits in general and not specifics of each component, we use some terminology that is generally applicable to any element. Now, the point of interconnection of many terminals, this is called a node. Okay. Now, how many nodes does this circuit have? This is a question for the participants. How many nodes does this circuit have? So I see a number of answers here. Many of you say it is 4, and that is correct. Okay, so we have one node here, another node here, another node here, and this whole thing it's written as an extended line, but of course this is a node. Okay, for convenience we write it like that, but if you just have a wire, that is a node. Okay, so we have 4 nodes in the circuit. Now, each element or whatever is connected between two nodes, such as this resistance here, okay, This resistance is connected between this node and that constitutes a branch. Okay. Now, how many branches do we have in this circuit? Each element, because we have only two terminal elements, each element corresponds to a branch. So, how many branches do we have in the circuit? So, many of you again said gave the answer correctly that there are 8 branches. Now, sometimes you can combine two parallel elements into a single element and call that a single branch. Right now, I will consider each of these things as a branch. Okay, each of these elements, that is a branch. So is this and this. So that's 5, 6, 7 and 8. Okay. So we have 8 branches. Okay. Now, when we say we have to solve a circuit, that is, we have to do circuit analysis, what it means is that you have to find the voltage across every branch, every element, and the current through every branch or element. Okay. So that's the meaning of the statement that I have solved for this circuit. Okay. Then you know everything about what each element is doing. Okay. For instance, if you have a voltage source, you can figure out whether it is dissipating power, whether it's consuming power, or how much power it is consuming or dissipating, and so on. Same for a resistor. So, given that, how many variables do we have to solve for? Okay. If we have 8 branches, how many variables do we have to solve for? Now, I see a number of answers with numbers like 3, 4, 5 and so on. But my question is the following, right? We have 8 branches in this circuit. Okay. Now, I want to know the current and voltage across every branch, and those are the unknowns, right? So, how many variables are there to be solved for? Perhaps the question is not clear. Maybe I will pose it as multiple choice so that everybody can take another shot at it. I opened a poll with the choices. Please answer on that one. What is the number of variables to be solved for? 4, 8, 16 or 20? Okay, now it appears that some of you have said 4 and some of you have said 16, and 16 is the correct answer, of course, because see, if you have 8 branches, each branch has a voltage and a current, and you have to find out all of it. Okay, now some of that may be easy, like for instance, if you have a current source, you already know the current through that, but that was not the point of my question. Okay, the thing is, there are 16 variables to be solved for, and somehow or the other we have to find 16 equations from which we can solve these 16 variables. Okay, now whether it's easy or difficult, that's a different thing. So finally, when you say that I have solved for this circuit completely, you have to specify the voltage and current in each branch, voltage across each branch and current through each branch. Okay, so that is what is meant by solving for a circuit. So in general, let's say you have a circuit with n nodes and b branches. Okay, you have 2 times b variables to be solved for. Okay, so in our case b is 8, but whatever the number of branches you have to solve for 2b variables. Okay, is this fine? Now the question is, what are the 2b equations? Okay, so this means that need 2b equations. Okay, now what are these? What are the equations that will govern our circuit? First of all, at every node you can write Kirchhoff's current law, and around every loop we can write Kirchhoff's voltage law, and finally we have VI relationships of each element. Okay, so from these things we have to pick the appropriate set of equations and then solve for the circuit. Okay, I hope this is clear so far. Now so let's go through these things one by one. As all of you know, to solve for 2b variables, we need to have 2b independent equations. Okay, because if you have some dependent equations, they are useless, right? I think all of you know what dependent and independent equations are. If you have a set of equations, now if some equation can be generated as a linear combination of other equations, then that's a dependent equation, meaning it's not telling you anything that the other equations are not saying. Okay, for instance, you have one equation over here, x plus y equal to 0, and let's say you have another equation which says 3x plus 3y equals 0. Clearly you can get this by multiplying the first equation by a factor 3. Okay, now if you do that, then that means that this is not telling you anything that the first one did not tell you. Okay, so this is dependent on first equation, so this is not useful. Now if you had a second equation which was, let's say, 3x plus 2y equal to 0, clearly you cannot get this by multiplying this by any number. Okay, this is an independent equation of this one. So using these two, you would be able to solve for both variables x and y. Okay, so now we have n nodes, and we know that at every node we have KCL equations. So my question is, how many independent KCL equations do we have if we have n nodes? So if we have n nodes, how many independent KCL equations do we have? At every node we know that the sum of currents flowing out of the node is 0. Okay, that is always true. But how many independent KCL equations can we generate? So some of you said n, and many of you also said n minus 1. Okay, and this is the correct answers. There are n minus 1 independent KCL equations, and that's because, let me take a simpler circuit than what I had before. These are some elements, right? While writing KCL, I don't care what elements they are because I'm only summing up the currents. Now let me call this N0, N1, N2, N3. Okay, and let me call these things I10, I12, I23, I20, and I30. Now what I'll do is I'll write KCL equations at every node, and my convention is to take the sum of all currents flowing away from the node. Okay. Sum of currents flowing away from the node should be equal to 0. Now what is the equation for N1? We have two branches, I10 and I12 as currents which are flowing away. So I10 plus I12 equals 0. Okay. And at node N2 we have I12 flowing in, which is the same as minus I12 flowing out. We have I23 flowing out and I20 flowing out. Okay. Minus I12 plus I23 plus I20 equals 0. Finally, at node N3, at node N3 we have I23 flowing in, which is the same as minus I23 flowing out, and I30 also flowing out. So I have minus I23 plus I30 equal to 0. That is at node N3. And finally at node N0 we will have I10 plus I20 plus I30 equals 0. Okay. So at 4 nodes I have written the 4 equations, but you see that, let me sum the first 3. If I sum these 3, the equations resulting at N1, N2 and N3, I sum the 3 equations. What will I get? I10 and I12 will cancel with this minus I12, I23 will cancel with this minus I23, and we will have I20 plus I30 equals 0. Okay. So the node at n0, the KCL equation at node n0 is the same as taking all the other KCL equations and summing them together. Okay. So the KCL equation here dependent on the KCL equations at n1, n2 and n3. Okay. So we don't have 4 independent equations, we have only 3 independent equations. Now in general, if you have n nodes, KCL at one of the nodes will be dependent on the equations at all the other nodes. Okay, and this is quite easy to see. Now this we have this circuit. What do we mean by writing KCL at node n0? Essentially, we take this closed surface and the sum of currents leaving this surface will be equal to 0. Okay. By the way, I have to change the notation on the last one. My usual notation was to take the currents flowing away. By this notation, at n0, the currents flowing away are minus I10, minus I20 and minus I30. Okay. So this last one should have been minus I10, minus I20 and minus I30. The equation I had written was correct, but the only thing was that the signs were reversed. Okay, but that doesn't change the fact that it is dependent on all the others. Okay. So when I write KCL at equation n0, I take this closed surface and say that sum of all of these currents equals 0. Sum of all of the currents leaving this surface. Now instead of looking at the surface surrounding node n0, let me look at this surrounding the rest of the circuit. Okay. So as it encloses this complete circuit, the sum of currents flowing in all these wires that are cutting the surface will also be equal to 0. Okay. Now you see that the surface enclosing n0 cuts these 3 wires and the surface enclosing the rest of the circuit also cuts the same wires. So what you get by writing KCL equations at n1, n2, n3 and then summing them together is exactly the same as what you get by writing the KCL at n0. So in general, if you have an n node circuit, there will be n minus 1 independent KCL equations. Okay, is this clear? I hope this is clear. If not, please ask your questions. Okay, now I think it's quite simple. The next thing is I have the same circuit with n nodes and b branches. Okay, how many independent KVL, Kirchhoff's voltage law equations do we have? Okay, please try to answer this one. How many how many independent KVL equations do we have? That is, you write KVL around every loop and you have to identify the independent loops. So how many independent KVL equations do we have? There are lots of loops, but we have to identify independent loops. For instance, I'll take the same simple circuit I had before. Now I have a loop here, I have a loop here, I have a loop here. Okay. So how many would I have? Now some of you have given answers and the answer seems to depend only on the number of nodes, and that's a little strange because you would think that the number of loops also would depend on the number of branches. Okay, because if you don't have a branch, then you cannot form a loop. Okay. Now I am not talking about this specific circuit. If you have a circuit with n nodes and b branches, how many independent KVL equations would we have? That's the question. Okay. Okay, so it looks like you're not able to identify. So let's go step by step. Now, how do we know how many independent loops do we have? So to do that, I will define what is known as a tree. Okay. So a tree is a set of branches, that is, out of all the branches we have in the circuit, we will choose a set of branches which cover every node without forming a loop. Okay, that is, what I mean is, in this circuit I could choose this, this and this. Okay, now they start from this node, go to this one and this one. So if I draw only that part of the circuit, okay, N0, N1, N2, N3. Now this will this set of branches covers all the four nodes N0, N1, N2, N3, but there is no loop that is formed. Okay, that is very obvious from this. Now this is not the only choice. We can have some other choice like this, and there are many choices. I am not going to list all of them, but for instance, you could have this and this one in the middle and this one. Okay, that is, this is N0, N1, N2, N3. So there are many possible trees, but what all the trees have in common is that they cover all the nodes without first of all without forming a loop. Okay, so now this should be easier to answer. How many branches are there in a tree? How many branches would be there in a tree? We have a circuit with n nodes and b branches. So how many branches would be there in a tree? Again, some of you are giving numerical answers. I am now interested in a general answer for a circuit with n nodes and b branches, not for this specific circuit. Okay.